Hello and welcome to the channel. This week I'm going to be building a prototyping rig. So basically we have a piece of aluminium which we can build our amp on in a frame that allows us to rotate it so you can see the underside and the top side, and you can work on it far easier. In a later video I'm going to show you an adjustable chassis rig so that you can turn the entire chassis over either way so that you can work on the top or the bottom of it. What we're going to need to build this chassis is some wood, some plywood and some aluminium sheet, plus some bearings. Now the frame itself is made from it's 37 millimeters by 75 millimeters, or 1.5 by 3 inch par, which is planed all round. So what happens is it starts off at 1.5 by 3 inches, or 37 by 75 mil, and then once they've planed it all round, this is what we this is the wood we get. I've run this wood through my tabletop router to take off a 4mm deep recess. You can get away without having that, but it just allows the chassis to basically seat better. I've cut it at 45 degrees like you're making a window frame, and this is glued with just normal tight bond and the dowel. So that gives us the frame, and along the shorter edge there's a hole cut in it. This is a 25mm or 1 inch hole. 2 pieces of ply. These are 100mm by 100mm, or 4 by 4 inches, again with the centre 1 inch or 25mm hole. For the uprights, these uprights are 50mm by 100mm planed all round, so they're just a bit smaller than that. They're 2 by 4. Height of these isn't critical, but it has to be high enough that when the holes line up there's a gap big enough for the corner to pass by without touching the bottom. Okay, so these are 30 centimeters or a foot tall. The base itself needs to be wide enough for all the components to go in, and there's an area at this far end which I'm going to leave empty for the moment, but what I'm going to do later is I'm going to show you how to build a variable AC power supply to fit in there so that you can have your adjustable power to build your amplifier. But for the moment we're going to build the actual chassis. The aluminium is 4mm. It's not critical. 1/8 of an inch, not a problem. The actual size of this aluminium, mine is 32 by 36 centimeters, so that slots into the groove. You can make the chassis as big or as small as you want. I personally wouldn't build an entire amplifier in one go on the chassis, so I think that this is a reasonable size. So that's 1 foot 1 inch by 1 foot 2 inch. That's just the size that this is. And then finally, even though it's glued and doweled, I'm going to put 4 strengtheners in the corners, and we have some bearings. Now these particular bearings are, I think they're designed for the bottom of stools so that the top spins round. I just got these on Amazon. It was less than £10 for 4 of them, but basically that's going to give us the ability to spin the chassis round so that we can work on the top or the bottom of it. These particular bearings are 7 centimeters, 70 millimeters square, with a hole in the center. Now you'll notice that the uprights, the spacer and the chassis all have a hole, which means that once this fits in place, we can pass power straight through into the chassis, and even if it's spinning, even if it turns round, the lead doesn't get in the way. And then the hole on the other side you could send out to your speaker, and again it just avoids cables getting trapped as it goes round. So I'll put a still in with the dimensions so that you can get the stuff, but basically this is all just scrap stuff apart from the bearings, so it's going to be a nice simple cheap thing to make prototyping a bit simpler. Okay, so first of all I'm going to show you the actual chassis mount. Now this is built with pine, just because it was what I had lying around. It doesn't really matter what you build it out of, and what I've done is I've basically used a chop saw to cut it at 45 degrees each end, just like you were building a picture frame. Now I have a router that sits into a table mount, and all I've done is I've used a flat top and I've cut this 4mm deep recess. It's not absolutely critical that you have that recess, it just makes it easier to locate the chassis. There will be some mounts on the edges to actually put the chassis in place. They've not been mentioned yet, but I'll get to those when we get to assembly. So basically this just needs to be strong enough. I put a dowel through them, you don't need to. These corners will do. Decent wood glue is stronger than the wood itself. This isn't going to be chucked around, so it should be fine. So what I'm going to do first of all is I'm going to add these strengthening corners. Okay, and that's now very strong. Okay, following building the frame, we're going to attach the spacers and the bearings. Okay, so we've mounted the plate and the bearing. Now this is going to be attached to here, but unfortunately you won't be able to get at the screws. So what we need to do now is we need to mark out where one of the holes is, and we're going to drill a hole straight through to the other side so that we can screw each one of these screws in turn as it rotates. So basically I'm going to use this carpenter's pen, excellent piece of kit, and mark through where the hole's going to be. Okay, oh, and I've even done that in the wrong place. It's going to be through the chassis side. Okay, so just here. and now I'm just going to drill that. Okay, so we've got a hole now drilled which lines up with the hole here, so as we rotate this around we're able to install the screw through the back. Okay, so using this hole I've been able to get to the screws that screw to the upright, and now you can see the upright now spins round and the bottom here will clear either side, so when that's fitted to the base we can rotate the chassis around in order to get to both the top and the bottom of it, and it spins freely. Obviously the other side is exactly the same, so I'm just going to do that now and then we'll move to the base. Okay, so I've completed fitting the bearing and the spacer to the other upright. So obviously this isn't screwed down, but basically this should now turn so that you can get to either the top or the bottom of what you're working on, and you can also have it at various different angles. What I'm going to do now is I'm going to attach it to the base, and then we're going to look at how you stop it rotating as well. Okay, so on the bottom we locate the edge of the centre of the edge and drill a small hole in the centre of the upright. So that's imagining that this was the centre, we're going to be drilling a hole here in the end, but this end. We then drill a hole slightly wider in diameter than the screw, and then we attach that one in place, and then measuring where the centre of the second screw will be, which you can do by measuring this distance here and adding half, and this distance here and adding half of this side. That will get you the centre of this screw. Drill straight through with a hole just a little bit wider than the screw, but only maybe a third of the distance. Then when you screw it in, it'll pull the base into the leg. So as it is at the moment, it's only attached by 2 screws, but basically we have the mechanism working as we expected it to. So what I'm going to do now is I can just put the other 4 screws in, and then we can move back to the top again. Okay, so I've put the other screws in. These screws, you need to make sure that they are countersunk, and this is something that I made just for the workshop. It's really handy. If you get a countersinking bit and then just glue it into a handle, one of the handles that you normally have that come free with, this one was free with a Ring doorbell, but basically it's just a plastic handle that takes the small hex screwdriver bits. So that's now super glued in there. That'll stay there, and what I can do is once I've drilled the hole, I can simply turn this round in the hole and it's countersunk. I'm actually using self countersinking screws, so I didn't need to, but you need to make sure that the head of the screw is below the edge of the wood in order to avoid scratching your worktop. Okay, to stop the metal plate from moving, I'm going to install some metal threaded wood inserts. Now to do this, what I'm going to do is I'm going to drill a hole using a wood bit that's a little bit wider than the screw size I'm going to use. This hole I'm going to drill down so it's a little bit longer than the screw as well. Then we need to drill a hole just a little bit bigger than that hole, which is just deep enough for the actual insert itself. So okay, that's that done. I can tidy that up with the countersink, and then we can fit the metal insert okay. That will bottom out on the wood that's in the hole from the second drill, but when we put the screw in, the screw will go right through the insert and out of the other side, and with a larger washer you can see that the washer holds the aluminium plate in place, so that's not going anywhere, and the plate can be turned upside down. Obviously at the moment I only have one of them installed. I'm now going to just finish off with the last one and install the screws with the washers, and then we'll take a look at it after that. Okay, so we've now got the four metal inserts into the wood with the screws going into them, and penny washers or large washers under the screw so that they reach the edge and hold it in place. As you can see now, we can rotate the metal plate in its holder round and round, and we can work on the back and we can work on the front. And if I rotate it round so you can see the back, you can now see that there's a hole right through from that side right into it, and there is on the other side as well. This allows us to pass cables in and out, and they don't get in the way when you're rotating it, although really you just want to be rotating one way backwards and forwards rather than round and round, because if you do it round and round you will eventually damage the cable or detach them from what they're attached to within. So that's basic. That's the basic chassis built. The only real issue is that when you add things to this, it's going to want to rotate. So we now need to work out a way to stop it rotating once we've got it at the angle that we want it at. Okay, so to stop it rotating, we need something to go through into the wood of the holder and lock it in place. And what I'm going to use for that is one of these. This is a threaded rod with a knob on the end of it, and it just allows you to turn it, and basically you're bolting the side to the actual chassis itself. Okay, so you need to make sure that when you do put the screw in, you make sure that it doesn't stop the corners of the spacer. If you want to move it further up, the only difference is you'll need to take the corners off the spacers and turn them into octagons, or at least on this side. That will allow you to move the bolt further up, but I'm going to have the bolts there so I can look at it there, and the same on that side as well. So I'm just going to drill that now and I'll show you the finished article. When you insert the threaded knob, you don't need to have a threaded insert. The upright is made out of solid wood, and because this is M10 and the threads are reasonably close together, it's going to cut a thread in the wood, and the thread will actually be strong enough to keep the threaded knob from actually coming out. So I'm a bit out of breath doing this. Right, so the threaded bar is now coming out of the other side of the wood, and we're going to continue that until it's almost touching the side of the panel holder. And as you can see, when I drilled the hole through, I held this at the angle I wanted it at, so that the threaded rod goes into that hole. Before you finish with the drill, you need to drill a hole on the corresponding side here, so that you can hold it the other way up. But once you've done that, you can leave that bar so it's nearly touching, and then when you want it held in place, you just do it the last few turns so it's now absolutely solid, it won't go anywhere. And by undoing this a few turns, it rotates again. So that then gives you the chassis for prototyping. What I'm going to do is I'm going to cut some nonal and some octal tube holes into this plate. You could cut holes for transformers, switches. Remember that a chassis has a front and a rear, so what you can do is you could effectively draw a line across here and across here, and this could be the back of your chassis, this could be the front where the switches and the knobs are, and have the rest in the middle. And what I'm going to do in one of the videos that's coming up is when I talk about how to go from a schematic to a layout and then building it, I'm going to use this, and we're going to build an amplifier on this plate. Normally you would build it straight into the chassis, but by having this, it does allow you to try out designs, see if certain things work, and basically it just allows you to get at both sides and finalize your design and make sure everything's right, and it's actually in a position where you could actually use it. One additional thing you can do is you can actually on the rear you can cut a piece of wood that's exactly the right size, maybe with some 4 threaded inserts, and you can actually screw a back onto it as well. By doing that, you've effectively got a fully working amplifier that you can use until you're happy with it. You might want to make modifications, and when you've got every single thing right, you can then lay it out on an actual chassis and build an enclosure for it. Remember, you've got the 2 holes to get into the chassis either side here, so your speaker out, your power in. The way I'm going to use this is by having a box at this side with a variable high voltage AC and 6 volts and 6 volts. So the 6 volts goes through for the heaters. I may well have that switchable 6 volts and 12 volts. I don't tend to use anything other than 6 really, so 6 would probably do. The high voltage side, I'm going to use a high voltage transformer, and then I'm just going to use a variac to adjust it. So by using the variac, you can adjust exactly the high voltage you want. It's going to be unregulated, but the whole idea of this is you're building a design that you will end up building into a proper chassis. So all the regulation, all of the smoothing and so on needs to be part of your design. So this just gives you that starting high voltage, so that you can make sure that the transformer you're ordering has the right output and so on. Okay, I hope that you found that useful. like I said, I'm going to be using this in some upcoming videos, and be nice to hear if anyone's built one.